Now it's time to create our game manager, which is responsible for controlling the state of the game. We'll be able to start a new game, return to the main menu, and even skip our intro cutscene using the game manager. We're also going to discover a popular design pattern known as the Singleton design pattern, which is commonly used in setting up manager classes throughout your game. The Singleton design allows you to access your manager classes directly without using the formal method of script communication using getComponent. It's perfect for anything that has only one instance, such as your game manager, your spawn manager, and your audio manager. Now that we have the ability for Darren to grab the keycard off the guard, what we need to do now is set up a game manager, because the next step in this game is to walk your way up the stairs and collide with this trigger zone, which will allow you to play the win cutscene, basically. So if we look at our level colliders here, we have a win cutscene zone. You walk into this, and it's going to play our cutscene for you win, and then offer you the ability to restart or not. So what we want to do is we're going to create a game manager that's going to control the state of the game. From here, we'll be able to do things like create a simple bool check to see if Darren has the card when he walks into this angle. We want to make sure that he can only trigger that winning cutscene if he has the key card. Otherwise, we'll have to go back and get it. Another thing we can use it for is for the ability to skip through the beginning cutscene, which will be working with the playable director through script to basically end it. So let's look at how to get started with this. We want to create a game manager, and we're going to do this a little different than what you're typically used to. Typically, the way we would do this is we would create a C# script called game manager, and we would add this to an object in the scene. Let's create a new empty game object and call it game manager. Here we go. And attach your game manager script to it. You can simply drag it over and attach it. Now your game manager script has a default Unity icon. It's just this gear setting. It's not a problem. You can keep it as the gear. So here we go with our game manager. Now typically if you were to create this, if the game manager needed to know when Darren grabbed the card, how would we typically achieve that? We would have the Darren script, which would be the grab keycard activation, would communicate with the game manager using getComponent, and the game manager would have a public variable that the grab keycard could basically access and turn the bool to be true. Now there's nothing wrong with that approach. However, when you're creating manager classes, typically what you can do in Unity and in C# in general is you can do basically what's called the Singleton pattern. It's called the Singleton design pattern, and it's a game design pattern that allows you to basically access the game manager without using getComponent. And it works really, really well for manager type classes because it's going to have one instance along all of the classes. Now don't worry if you're not following along. As we create it, it's going to make a lot more sense. So let's open up our game manager script here. And the first thing that we need to do is we're going to delete all of this. When we are working with a Singleton design pattern, we need to have a static variable that's going to be used to access this class. So when I create a static variable, such as private static, and let's call this like int, let's call this private static int myInt, okay? Here we have a variable that's just a normal variable. If I remove the static, you're familiar with this private int myInt. However, if I add in the static keyword, what does that mean? What does that do? That means that this variable is now going to be accessible through every class. It's in-memory indefinite. You never want to make your traditional variable static. However, when you have a class that's only going to be instanced once, meaning that we're not going to have more than one game manager. We have one game manager. We're going to have one audio manager. We're going to have one UI manager. Anything that is a manager class and you're only going to have one of them can, and for the most part, should be a singleton. So when I add this static variable, it's going to make it so that this variable is in memory indefinitely. What we can do here is make it so that this class is in memory indefinitely so that you can access it. So we can say private static game manager, and we're going to call this underscore instance. This is going to be the instance to access this game manager. The reason why it's private is because we don't want anyone to ever be able to reassign the value of this instance. It's always going to be assigned to this game manager. Following this, how can we then access this variable? Because I need to access it. We're going to create what's called a property. We're going to create a property called public static game manager capital instance with a capital I, instance with a capital I. And we're going to create what's called a property. A property is just like a variable, except for the fact that instead of a semicolon, you open it up with a curly brace, open and close curly brace like a function. Now, a property, you're not new to properties. You're new to creating them, but you've actually seen them pretty frequently. If I create void start down here, you'll notice that if I type transform.position and I say equals, and let me go ahead and get the tooltip so I can demonstrate this. Let me save my script here. Head back into Unity, let it compile. It may not like the fact that my property is incorrect here. We'll talk about getters and setters in a minute of why it's erroring out. So let's save this. And like I said, you're not new to properties. You're just new to creating them. But check this out. If I type transform, once I get my scripting reference back here. Okay. So in here, when I type transform.position and the tooltip pops up, you see where it says here get set? Those are properties. The reason why you can even get and set this is because that property defined it as such. That's how you can know you can get the value of transform.position or you can set the value. It's a property. So what we can do here is we can actually create our own get and set methods. So here we have public static game manager instance, and we're going to create a property. The syntax for the property is you create your static, or you, I'm sorry, not static, but you create your variable as you typically would, and you add in these curly braces. From here, we need a get, and you can just do get semicolon, and you need a set semicolon. Now this right now acts as a traditional variable. You can get the variable, you can set the variable. Something unique you can do is if I want this information to be available to the public, but I only want this class to set this variable, I can set this to private set. And that means that this variable can only be set in this class. However, it could be accessed by other classes. To actually set this variable, you would just assign it like a normal variable. Instance equals like 5 if it was an int. You just assign it like a normal variable. It's the same thing. So here, what if there's another unique opportunity with properties, and that's that you can actually execute code before getting the value of instance or whatever variable it is and returning the value of instance. So when we're creating a singleton here, we're going to return this underscore instance because that's what we actually want. That's what's actually going to give us the access to this script. So to get that, we're going to have a get, and it's going to have its own little property here. And then we're going to have a set. And within these brackets, we can actually run some code and we can say, hey, do this before returning the value. And same thing goes for setting the value. You can actually run some code before setting the value. Now, it's really important with this instance that we never let anyone set the value of the instance. So we are actually going to delete the set, and it's going to be get only. In here, we need to return something. And what we're going to return is the underscore instance. So now this is a fully functioning property. When we access this from another script, when we say instance, like instance whatever, it's going to return the variable underscore instance, which is going to be used in this script and give us access to the static reference. So here, to continue on, what we want to do is we want to make sure that this variable gets returned. From here, we want to make sure that there's only one in the scene. So we want to make sure that there's only one in the scene. So in order to do that, we need to actually null check this. We're going to check to see if underscore instance is equal to null. And if it is, that means that this game object got deleted or there's nothing in the scene for it. So there's nothing to actually return. If this instance is null, we want to throw an error and tell the developer, hey, the game manager is broken. So here we're going to say debug.log error. And this is going to allow us to create an error message. And we're going to say game manager is null. We always want the game manager to be in existence. If you access the game manager and you delete the game object that hosts this script, you're going to run into some serious problems. So if the instance is not null, then we just return the underscore instance. Now, where does the instance underscore instance get assigned? When the game is loading using void awake, that's when we're going to assign the instance. We're going to say underscore instance equals this script that the object is attached to. This script, this game object that we have this script on. Okay? So here we have private void awake underscore instance equals this. Everything you see here is the Singleton design pattern. This is how you create it, and this is the best practice for creating one. Now, the design pattern takes a little bit getting used to. Setting up every time, a little bit getting used to, but I promise with time and experience, you're going to love the Singleton manager. So what is so great about this? Why is it something we're interested in? Well, check out how easy it is now to create information and access it. So what we want to know is, did Darren successfully grab the card? So we're going to have a public property here saying public bool, and we're going to call it has card. Typically when you create properties, it's best syntax to use Pascal casing, very similar to function creating. So public bool has card. All right. And what you can do is you can create a property for it. You can't leave it like this. There's no default implementation. And actually there is. If you leave it like this, public bool has card, then it's just a regular variable. But we want to actually use properties. When you're working in a manager class, you want to use properties. So what we can do is we can create a property, and we can get the value of has card, and we can publicly set the value of has card. If you wanted to add logic in here, you would have to create a get function like that and a set function like that. Another thing you can do is called an auto property. So public bool has card, and the syntax for an auto property is this. You do get, set. Very simple. All in the same line, just like this. So these are auto properties. So here we have public bool has card. What we can do now is from our grab keycard activation, we want to signify to the game manager that Darren has the card. So how do we access the game manager? Typically, we'd have to create a handle to the game manager, and then we'd access the component, right? So we would basically be doing game manager, and we'll say GM equals, we have to find the game manager. Once we find the game manager, then we can get the component we want, and we can say game manager. Now we have a reference to our game manager, and if we type gm dot has key or has card, this is how we would typically fill it in. So if we could do it this way, why use the manager? Because watch how we can eliminate the need to use getComponent when working with manager classes. I can simply just type the name of the manager class, which is game manager, and I can type .instance. That's the public property that returns the underscore private property. So here we have game manager.instance, and then I can type dot, and I can get every public value in that manager class. So I can say game manager.instance.hasCard, and you can see here that it says get set. That's our property. So hasCard equals true. If we save this, we're good to go. There is nothing more that we need to do. Now, the downside to using the Singleton design pattern in your manager classes and using properties in general in your manager classes is Unity cannot see properties by the default inspector. If we select the game manager here, we have that public variable or that public property, but it's not going to be visible in the scene. You'll see here that it's only visible if we go into debug mode. There you can see that we have a property called hasCard. In the next video, we're going to set up the interaction to trigger the final cutscene and test this win condition. In this video, we're going to set up our trigger system around the cutscene zone. So here, very similar to our grab cutscene zone, you're going to do the same thing. The first thing we want to do is make sure box collider is set to trigger, add a rigid body component, make sure use gravity is off, and from here we're going to create a new C# script that is going to be housed on that object. So here we're going to create a new C# script, and let's call this win. Let's see, we called the other one grab keycard activation. Let's call this win state activation. And this will trigger that cutscene. If we open this up, we're going to delete the code that's in here. And the logic, right, is we need the on trigger, check for Darren. The next thing we need to do is we need to check if you have that key. So check the game manager for key. We have on trigger, check for Darren. We're going to check the game manager for the key. If it has the key, what do we need to do? If it has the key, we're going to trigger win cutscene. Else, what are we going to do? Else, print a message that says you must have the key, right? All right, so print out a message that says you must have the key. I'll see you guys in the challenge review. In this challenge review, we're going to set up our win state activation. So the first thing we need is our trigger to be able to detect Darren. So void on trigger, enter, collider other. We want to check for Darren, which is our player. So if other.tag is equal to player, then we have a collision. And what do we need to do? We need to check if he has the key or not. We only want him to win if he has the key. So if, we'll say if, and we need to check the variable inside our game manager. So we're going to say game manager.instance.hasCard equals true. If that returns true, then we need to trigger the win cutscene. So that's going to be a public game object that's going to house it. So public game object, and we'll call this win cutscene. From there, we will activate that object and set to true. All right, now what happens if you don't have the key? We're going to say else, we'll debug.log, you must grab the key card. Alrighty, and it looks like that's everything we needed. Let's go ahead and save this, head back into Unity, select your win cutscene zone, make sure your script is attached. Once Unity is compiled, we need to drag the level complete cutscene to the win state. So here we are, level complete cutscene goes there. Save your scene, let's run Unity, and we'll make our way back past the guard and we'll go ahead and see if this works. So I'm going to play this, get to the guard, and I'll see you guys when I get to the security, sneaking security guard. Here we go. I am now grabbing the key card. So in our manager class, that should have triggered that we tried to grab the card. We're going to go ahead and go up the stairs now and trigger into our winning cutscene. So we're going to travel up the stairs. Let's head up here. And because we have the key card, it should trigger. Now, looking at this, it's not triggering. So the question is, why not? If we look at our win cutscene zone, we have a box collider with trigger checked. We also have a rigid body. So we have all the required components. However, we're not triggering this box. And if we actually click on that, let's see here. According to the win cutscene zone, what are we missing? Let's open up the script and see if there's anything in here. If other.tag is player, if has card is true, we want to do that, else we want to do this. Now I don't see any messages in here at all. So there's no log messages. If we click on our game manager, and if we go into debug mode, we can view the bool. You can see here, has card is indeed true. So what happened here that our cutscene isn't activating? If I had to guess, it's because when we turned off our sleeping guard cutscene, we turned off this parent cutscene object. And I believe that's controlling this from playing. So we may need to consider another option here. What happens if I try and turn this game object on? Nothing. However, I believe if I turn the cutscene object on, they're going to be battling it out for who plays. So we created an issue here where we need to turn off the parent object of the sleeping guard. However, it's affecting us from actually being able to play any other cutscene. So in the next video, I'm going to show you a solution on how to fix this. I'll see you then. In this video, I want to take a look at why we couldn't activate the level complete cutscene. And it comes down to how we closed our sleeping guard cutscene. We did so by closing this parent object, which closed all of these other game objects. And because the parent is closed, meaning it's off, we can't open or awake any of these. So what we need to do is we need to actually isolate the sleeping guard a bit. We need to create an empty game object that's going to act as a housing agent for our sleeping guard. So here, this is going to be our sleeping guard. We'll call this cutscene holder. Okay. Inside here, you can zero the position out. Drag the sleeping guard cutscene inside here. And inside your timeline track for the sleeping guard, if you select it, we want to change this cutscene parent object to be the sleeping guard holder object. And that's all we had to do. If you save your scene, test it out again, we should be able to collect the card and get to the winning cutscene. I'll see you guys when I get to the guard. Okay, so I'm at the guard here, and let's go ahead and run this. I accidentally already triggered it, so I might not be able to again. However, if I turn on the game object here as a parent, it should go through again. So here we are. We're going through our cutscene. And as soon as it ends, the sleeping guard's off, and we can go ahead and continue on. Let's make our way up the stairs. We have the key card. All right, we'll go up the stairs. And as soon as we trigger into this, we should have our winning cutscene. And there you go. Now, right off the bat, what do you know? Our game asset is visible. So what we need to do is modify that cutscene. So if you select your level complete playable director object, we can open up the cutscene here. We need to hide Darren. So to do this, we're going to create an activation track. From there, we are going to add our player game object. So here, drag your player in there, and we do not want him active. So we're going to move this all the way to the very end and make it the very last frame. So you can actually just select it and select the start frame to be 4:10 and have it end at 4:11. All right, so for one frame, it's active, it comes back. But by that point, we're already in a fade to black and we're ready to restart the game. So let's save this. If you want, you're more than welcome to test it out, run it again, but we should be good. So in the next video, we're going to go ahead and take a look at some audio, and then we're also going to get into some more functionality of the game. I'll see you then. In this video, we're going to clean up some of our audio. Now, you may notice that when you're playing your game, we're going to go ahead, we're going to have some audio trigger right about now.
Darren, if you toss a coin in another location using the right mouse button, then the guards will be distracted.
Notice that as the camera changed, the volume shifted, and now it's only coming out of the right microphone for me, or the right speaker. The reason for this is because of how we're instantiating the audio. When we instantiate an audio clip the way we are, it is now creating, basically it's using spatial audio. So our camera, our main camera, has a component called an audio listener. And when you instantiate a clip, it's almost like a 3D sound. And the closer you are to the camera, the louder it is. So that's not really the ideal behavior we want. We actually want a very consistent sound. Now, to have a consistent sound, the easiest way is to have a dedicated audio source for those clips. So what we're going to do is we're going to create a audio manager that's going to be responsible for playing all of the audio clips in our game. So we're going to start off with the voiceover audios first. So the way we're going to do this is let's create an empty game object and call this audio manager. Inside this audio manager, it's going to house all of our audio. So for example, let's go ahead and zero this out. Once you've done that, let's create another empty game object and let's call this voiceover, or VO for short, and drag that into your audio manager. And what I would like you to do is go ahead and add an audio source component. This is going to be the audio source dedicated to our voiceover triggers so that we have a consistent sound. The idea here is that we are going to have a audio manager script that's going to have a function or a method, and you're going to be able to pass in an audio clip it should play, and it will play it using this audio source. So that's the goal here. What I'd like you to do now is let's create a new C# script, and let's call it audio manager. Now, because it is a manager class and we're only going to have one audio manager, you should turn this into a singleton so that we can access it more easily. Drag this onto your audio manager game object. With the audio manager attached, what we're going to do is we're going to turn this into a singleton. Now, you've only created the singleton once with the game manager, so I'm not expecting you to know how to do it again right off the bat. But let's go ahead and discuss the logic for what is required for the singleton. In order for you to even access the singleton, it has to be embedded in memory and span across all classes so you can access it, basically make it accessible. So to do that, we need a static variable instance that's going to be designated for this class. So we need a static variable instance for audio manager. All right, so static variable instance for audio manager. You need a property to access that instance. The reason why that's going to be a private, and this will be private static variable instance for the audio manager. The reason why we want it to be private is so that you can't reassign it. We want this to maintain its value with the audio manager indefinitely. The next thing is, how do we access that private variable? Well, we access it with a property. So you need a public property to retrieve the audio manager instance. All right, so inside the property, you need to first check if the instance is null. So if the instance is null, check if instance is null, then you want to throw an error. That means that you forgot to create the script in the scene and so forth. And I'll demonstrate an error for you in just a moment. So here you want to check if the instance is null, throw error if it is, else return the instance, and we can use it. And then you want to assign the instance. Assign the instance to this script in void awake, which gets called during the loading process of Unity. So go ahead, take this pseudocode, and try your best to create a singleton design with this. In this challenge review, we're going to set up our audio manager. So go ahead and open up the script. The first thing we want to do is create our private static instance variable for the audio manager. This is going to embed the audio manager in memory while the game is running. So here we're going to say private static, and we'll call it audio manager for the data type. And we're going to say underscore instance. This variable is going to allow the audio manager to be embedded so that we can access it from anywhere. All right, so we have our private static audio manager instance. We now need a property to return this instance. So here we're going to say public static audio manager, and it's going to be capital I instance, and this is just a property. It's also a static property because we want to be able to access this instance from anywhere. Okay, so instance, and we're going to have a get. So when we get this instance, we need to return the underscore instance. Now, before we can return it, we definitely want to check if it's null. So here, if the underscore instance equals null, we're going to debug.log an error. Debug.log error. And we'll go ahead and say that audio manager is null. Okay, so our audio manager is null. Let's save this. The next thing you need to do is here's our singleton, but in order for this to actually work, we need to assign it and void awake, which happens when Unity is loading. So here you want to say underscore instance equals this script. So this script, there's only one of this script, there's only one audio manager, and it's this audio manager. And that is how we create our singleton design. So here we go, we have our audio manager. In the next video, we're going to go ahead and set up how we would turn this into a modular function to trigger all of our voiceover audio. I'll see you then. Now that we have our audio manager set up, we can now call this from anywhere. Now let's go ahead and look at some of our voiceover trigger script. We have a modular voiceover trigger script here. The problem with it though is that we're using audiosource.playClipAtPoint. Instead, I actually want to communicate to the audio manager and say, hey, go ahead and play this voiceover track or this voiceover track and so forth. So we actually want to pass this clip to play to the audio manager and have it be responsible for playing the audio so that it plays in a 2D setting and not a 3D setting. So let's look at some of the options of doing this. First off, our audio manager needs to know which audio source it should play from. If you look on our audio manager game object, we have this voiceover game object that has an audio source. Our audio manager needs a reference to this voiceover object. So let's create that reference. Open up your audio manager. And inside here, go ahead and let's create a game object to hold that voiceover. More specifically, we want the audio source from that voiceover. So we can say public void or public audio source. And we're going to call it voiceover audio. So we'll say public audio source voiceover. Save this, head back into Unity, let it compile, and on the audio manager, it's now looking for a voiceover audio source. Drag the voiceover into that slot. So we're going to take the voiceover and drag it into the audio source. Now our audio manager knows which voiceover it can play from. So looking at some of the functionality of the voiceover variable, when we type voiceover, we have a few things we can do. We can play the audio clip assigned to that voiceover audio source. We can also assign a clip by saying voiceover.clip. And if we look at the tooltip here, it says the default audio clip to play, and you can get and set it. So we want to basically assign whatever clip the voiceover trigger is going to send us. Now the question is, how is it going to send us anything? Well, we're going to have a public method here called public void, and let's go ahead and call this play voiceover. All right, so we call this method play voiceover. How does our voiceover trigger communicate with this function? Well, it does it very easily. Because we are using a singleton manager, we can simply type audio manager inside the voiceover trigger, audio manager dot instance dot whatever that function name is, which is play voiceover. So here, play voiceover. And just like this, we've now called that method, but now it needs to know more information. It needs to know what track to play. So what we're going to do is we're going to go back to the audio manager and we're going to pass in a parameter of audio clip. So here we're going to say audio clip, and that's just the data type of the parameter we're looking for. This could be an int, it could be a vector3. I want an audio clip. So here we're going to say public void play voiceover audio clip, and we're going to call this clip to play. Let's save this, head back over to our voiceover trigger, and when we retype .instance .play voiceover and open a parenthesis, it's asking us to pass in a clip to play. And we're simply going to pass in the variable that's holding our audio clip. By doing that, the game manager or the audio manager now knows what clip to play as it's stored in this local variable. From there, you can simply type voiceover.clip is going to equal the clip to play, which is what we received from the voiceover or from the voiceover trigger script. And after you assign the clip, we can say voiceover.play and just call it like a function. If we save this, head back into Unity, and you want to select your voiceover audio. You want to make sure that play on awake is off. You want to make sure that spatial blend is set to 2D here. From there, run your game, and we should see that as we progress through the game with the voiceover track playing and the camera switches, the audio should be very consistent. So I'm going to go ahead and walk over here. Wait for this guard to leave.
Darren, if you toss a coin in another location using the right mouse button, then the guards will be distracted, allowing you to sneak on by. Give it a shot.
Now, what happened there? It actually wasn't 100% perfect. And the reason for that, guys, is because if we look at our voiceover trigger, I'm still instantiating a play clip here. So remove that line of code and only have our audio manager code. Let's save that and run it again. Let's walk over here. All right, and here we go.
Darren, if you toss a coin in another location using the right mouse button, then the guards will be distracted, allowing you to sneak on by. Give it a shot.
And there you go. So there we have successfully completed the audio, and it's very consistent. Doesn't matter where the camera angle is, it's now just a 2D sound. Now for the voiceover, if it's too loud, you can just modify the volume of our voiceover object. All the voiceover is going to get passed through here. So we can just simply set it to say 0.7 so that it doesn't overpower the game audio or anything like that. I'll see you guys in the next video. In this video, we're going to add some life to our game by adding in some background music. So what do we want to do is right-click our audio manager and create an empty game object under it. Go ahead and create a new empty game object called music. From here, add an audio source component and add the audio clip of ambient music. If you open up your folders, inside our game folder here, we have audio, music, and we have a few music audio cues that we're going to be incorporating here. So ambient background music is our game background. So select your music game object and drag the ambient background music clip into the audio clip. We want to play on awake, and you can set the volume probably to about maybe 0.7. We don't need it to be too loud. Save your scene and run this. Now I ran this in play mode, which means nothing's going to save. So I need to re-go through that process of creating empty. Music. Add an audio source. Drag the ambient background music. Play on awake is on. And set the volume to about 0.76. Save your scene, run the game, and let's see how this sounds. So it's a little loud, so I can control the volume and maybe set down to about maybe like even 0.3 for me. But find what's comfortable for you. And the idea here is now we have
Darren,
a more
if
live...
you toss a coin in another location using the right mouse button, then the guards will be distracted, allowing you to sneak on by. Give it a shot.
Alright, so I definitely recommend you find an audio level that's comfortable for you. And the next thing I want to do is when we get caught, we actually have a game over stinger, so we're going to add music to getting caught. But last but not least, before we go, click on your audio manager with the game off. There's one more thing you want to make sure you're doing with the music. Make sure loop is checked. That way the soundtrack isn't going to play once and just stop. So go ahead and find some audio levels that are comfortable for you. I'm probably going to keep mine around 0.27, and for my voiceover, I'm going to move it down to about 0.4. Yeah, but I'd say about 0.4. All right, I'll see you guys in the next video. In this video, we're going to be adding the game over stinger for when Darren gets caught. So very similar to how we added audio to our other cutscenes, we want to basically select our game over cutscene, enable it, so that we can see it in the preview here. And what we want to do is we have an audio stinger and a voiceover track. So let's create an empty game object here that's going to handle the audio for this cutscene. Very similar to what we did with the intro cutscene, where we have an audio game object, voiceover, and music inside. We're going to do the exact same thing. So inside your game over cutscene, create empty, call it audio, and inside here, we're going to have two other game objects. We're going to have an audio game object for music. So right click, create empty, music, and duplicate this and call it voiceover, or VO for short. On both of these, add an audio source component. From here, play on awake is going to be true. Select music, and let's add the discovery stinger. That's when Darren gets caught. That's going to be our music. And on the voiceover, we're going to play. We have two options here. Darren is caught and Darren is caught other. You can choose which one you like.
Oh man. Hang in there, Darren. We'll get you out.
And then we have...
Darren, are you there? Darren!
All right, so I'm going to use Darren is caught other. So select the voiceover object and drag Darren is caught other into it. Take it and drag it into the audio clip. From here, save your scene. And now we need to actually make use of this in our timeline track. So select your game over cutscene, and we're going to add an audio track. From there, it's looking for an audio source. So drag your music audio source. And from there, we can choose add from audio clip. From here, we want to basically select which clip we're going to be playing. Now you can actually drag in directly by selecting the discovery stinger. Go back to your playable director and drag your discovery stinger in there. And there we go. So this discovery stinger is going to be playing from the music voiceover track. So once we have that, we should be good. We have our discovery stinger, and then we start the voiceover. So we're going to add audio track. The audio source for that is the voiceover. And then once you do that, you can drag in the Darren is caught other. And here we go. So we might want to start the communication of Darren, or Oliver talking to Darren about right here, I'd say. So it plays the stinger and then Darren comes in with the audio. All right, I think that's going to look really, really neat. So unfortunately, at the current time of the recordings with version 2017.3, we can't hear audio in the inspector, so we actually have to run this. So go ahead, save your scene, and run Unity.
Oh man. Hang in there, Darren. We'll get you out.
All right, there we go. So it might be very loud, and I apologize in advance if that was extremely loud. So what we can do here is if you actually select the music and voiceover, let's modify their volume takes and set the volume way down low to like 0.4. Find what's comfortable for you. All right, go ahead and save this. Make sure you close the game over cutscene. All right, so we're back to normal. Save your scene. This is also a great time to publish your changes. You always want to make sure that you are publishing your changes to the Unity Cloud services and using Collaborate. All right, the last thing you want to do is lose a bunch of work, so make sure you commit often. So here we are. Added sound, added audio manager. Added audio manager and game over cutscene sounds. All right, hit publish. I'll see you guys in the next video. In this video, we're going to begin polishing up this game and getting ready to create the skip cutscene functionality. So what we want to do is when the game first starts, we want to make sure that the intro cutscene is on so that it automatically plays. Now we may need to add some things to our timeline here to control the actual game audio. We want to make sure that the voiceover, or more specifically this background music, we want to make sure that this doesn't actually start until the end of our cutscene. So we may need to create some code functionality for that, but let's see how it looks. Let's run the game and test it out.
Oliver, I'm here.
So there is definitely some overlap.
We didn't run into any trouble. Darren, you've made it into
Yeah, there is some
the grand
overlap. So
foyer of
you can see here the music is
Beatrice
different.
Auction house. The items in this room are worth millions.
So go ahead and stop playing. We want to make sure that this music doesn't actually start playing until the end of the cutscene. To get that result, one of the things that we can do is we can actually animate this audio manager and control the music volume. So at the start of the intro cutscene, it's going to be no volume, and then by the end, we'll fade it back into, say, full volume. So to do that, what we want to do is look at our intro cutscene timeline, open up your audio tracks, and we're going to add a new audio track. So here, audio track, and drag in the audio manager. And actually, we don't want to create an audio source. We actually just want to drag in the music. So that music game object here, that's a part of the audio manager, has an audio source. That's what we want to grab. From there, hop back into your intro cutscene timeline. And we basically want to say at the very start, okay, at the very start, what do we want to do? We want to make sure that that audio is set to 0. So actually, I can't animate anything on that audio source. So instead, we're going to delete this track, and we're actually just going to create an animation track because we want to animate that object. So create animation track, drag your music into the animator slot, create an animator on the music game object, and from there, with the playable director selected, we can now animate this. So at the first frame, we're going to select our music, and our volume is going to be set to 0. Now for me, the max volume is going to be about 0.274. So here, we're going to say 0 to create the first frame. And then at the very end, we're going to go ahead and set it to, say right about here, we're going to go ahead and set that to 0.274. And there you go. Stop playing this. Go ahead and turn off all of the music or the intro cutscene. Save your scene. And let's go ahead and run this. Make sure your intro cutscene is actually turned on. We want this to play when we hit start. Run the game. All right, and there we go. So as of right now,
Oliver,
our audio
I'm
is off.
here.
Good.
And you
I
can
hope
see
you
here
didn't
that
run
we
into
can
any
see
trouble.
our player Darren
Darren,
and our
you've
actor
made it
Darren.
into
So
the
we're going to want to
grand
hide the
foyer
game
of
asset in the next
Beatrice
video.
Auction house. The items in this room are worth millions.
I feel underdressed. So where's the main vault?
Unfortunately, on the other side. Do you see the guards? Watch their patterns to see how to get past them. Now, look at the security cameras. Those cameras won't see you if you're directly under them. Just move when they aren't pointed in your direction.
Anything else?
Do you see that guard over there? The one reading a magazine. He's been on that same page for the past hour. I guarantee you he's asleep. And he's got a key card hanging off his belt. You'll need that card to get inside the vault.
This ain't my first rodeo, cowboy.
Noted.
So we have a few problems here. Very similar to what happened with our actual level complete cutscene. This intro cutscene needs to turn itself off. And just like our sleeping guard cutscene, we have to now isolate it. So there's a few things we need to fix here. However, the audio, I believe, did indeed work, because if I select my music here, my volume is at 0.274. So while that worked, we need to now focus on fixing the other issues. So I'll see you guys in the next video. In this video, we're going to look at how to hide the actor Darren, very similar to how we did so in the Sleeping Guard. If we bring up our Sleeping Guard cutscene, you can see here that we have an activation track for our Sleeping Guards. And you can see here that the Sleeping Guard activation, it gets activated, the game asset at the beginning, and then we have the actor's asset for the entire scene. We're going to do the same process. So select your intro cutscene, and let's create 2 activation tracks. We're going to create 1 activation track for the actors and 1 activation track for Darren. Make sure you create an activation track. Okay, so for the first one, we're going to place our actors in there. So drop down your intro cutscene, drag the actor's game object into the slot, and from here, we're going to grab our player game object and drag him into the second slot. So the actors, we want them to be active for the entire scene. So we can go ahead and set this to be the end of the frame. And we want this actually shut off at 3773. All right, so 1 frame before the end. Now for Darren, we want him to be off the entire game, but we want him to return at the very last frame. So here, if we look at the last frame, we want this to be 37. Looks like the last frame is 3785. So 3784 is when we want to actually enable Darren. So 3784 and 3785. All right, so that's the final frame. So the very final frame, we're going to activate Darren. And here we can go ahead and set this to be the length of whatever the final clip is. All right, so one frame before the end. So 3785, so 3784. All right, so this is going to play through, and if we check this out, we should be able to see in the inspector here, the actor is there. When I get to the last frame, the actor disappears, and we should see Darren come back. So I'm not seeing Darren come back, so we want to make sure we actually get Darren in there. So let's go ahead and start this at 3783 perhaps. 3783. As long as it happens during the fade effect, we're okay. And here we go. All right, so the actor is gone, but Darren is not coming back. So why would Darren not be coming back? Let's drag him out a bit. And here we go. Okay, so let's make sure that he comes back in about here. Okay, and that actually works pretty well. So here Darren is active. So we're already fade to black and Darren came back. So let's make it a little bit shorter. And about right there would be ideal. All right, here we go. So Darren is back and our actors disappear. All right, good deal. And then we end the cutscene. So that is hiding our game asset. But now we have a problem with our cutscene itself. We need to actually isolate this cutscene and do a similar process to how we isolated the sleeping guard. So to do that, we're going to take our cutscene here and we are going to isolate it and make it its own object in the scene. We're going to create a new empty object to act as the parent holder. And we're going to call this intro cutscene holder. And this object is just used to activate and deactivate the intro cutscene. Unfortunately, this is the only workaround at the current time to activate and deactivate a game object of itself. So what we want to do now is on the intro cutscene timeline, we're going to add another activation track, and we are going to add the intro cutscene holder. The intro cutscene holder is going to be active for the length of the film, but we are actually going to short it one frame. So 3784 should actually be okay. All right. So what we can do now is we can save our scene. We can keep this game object on, and it should turn itself off. Darren should reappear, and our music should be okay. So let's go ahead, save your scene, and let's test this out. Let it run.
Oliver, I'm here.
Good. I hope you didn't run into any trouble. Darren, you've made it into the grand foyer of the Beatrice auction house. The items in this room are worth millions.
I feel underdressed. So where's the main vault?
Unfortunately, on the other side. Do you see the guards? Watch their patterns to see how to get past them. Now, look at the security cameras. Those cameras won't see you if you're directly under them. Just move when they aren't pointed in your direction.
Anything else?
Do you see that guard over there? The one reading a magazine. He's been on that same page for the past hour. I guarantee you he's asleep. And he's got a key card hanging off his belt. You'll need that card to get inside the vault.
This ain't my first rodeo, cowboy.
Noted.
All right, and there we go. So Darren came back, which was great. However, this cutscene object is actually still on. So something happened in our timeline where it didn't actually turn that object off, and we want to make sure that that happens. Okay, so I'm going to run it again, and I'll pause the video and get back to when it's at the 55-second mark. So here we are at the end of the cutscene. The actor should go away, and there's Darren. So in order to actually get this result, there's a couple things I actually had to do. The intro cutscene here, you want to make sure that the wrap mode is none. Okay, we just want to shut off. But then also the actors, all right? In total, there are 3,750 frames. The actors, we want to go to the very last frame -1. So 3749 is 1 frame before the end. Same for the intro holder. We want that to turn off at 3749. And then we have the game asset. The game asset's going to turn on at 3749 and end at the very end of 3750. So what's going to happen is it goes through all the way, turns on Darren, and shuts everything off at the same time. And Darren comes back. It's a little bit of a process, and hopefully in the future it will be a lot easier to enable and disable actors in timeline. All right, guys, that wraps up the additions to fixing everything here. I'll see you guys in the next video.
I guarantee you he's asleep. And he's got a key card hanging off his belt. You'll need that card to get inside the vault.
This ain't my first rodeo, cowboy.
Noted.
So in this video, we have one more problem, and it's the fact that our camera isn't pointed at Darren. So we have here that everything is fine. The actors go away, Darren comes back in the scene view, and he's ready to go. However, we need our camera to get positioned. So very similar to the same process we did with the sleeping guard cutscene, we need a virtual cam that's just going to basically give control back to a view for Darren. So the idea scenario here is we want to actually align it with one of our camera angles. So to do that, we need to stop playing. We're going to go to Cinemachine, create a new virtual cam, and we're going to call this CM Final. So CM Final Shot. And this is going to give control back to the main camera so that we can actually play our game. So you have CM Final Shot. And what we want to do here is I'm going to disable the intro cutscene for a minute so we can see. And for the CM Final Shot, I want to position it inside of our camera progression angles, and I want to put it inside of camera 1. From there, I want to set the rotation values and position values to 0. And my hope here is that it would take the rotation and position value of that. If I hit solo, you can see it did exactly that. So what we can do now is we can take the CM Final Shot, bring it out of there, and we should have a pretty good shot of Darren here. And let's go ahead and solo this. All right, we may need to make a few adjustments, but for the most part, I think that's actually pretty identical to what we start with. So here I would be okay with. Now, the next thing you want to do once you have the angle correct is we're going to take the CM Final Shot and we're going to drag it into our cutscene with our other CM virtual cams. So take the CM Final Shot, place it inside here. It's now off, and we now need to include it in our timeline. Select the intro cutscene that has the playable director, and we now need to make it the final camera. So here we have this cam, which is CM Darren End. We're going to end it a little bit sooner. So we're just going to shrink it down here. And if we look in our timeline here, click preview, and make sure that your intro cutscene is on so we can actually modify this in the inspector. So here we are. At about right here, we've already gone fade to black. So it's okay that we're changing the camera here because the player won't even see it. So we want to right click here, and we're going to add a Cinemachine shot clip. And that's going to take up the rest of the length of the animation. The virtual cam it's going to use is the virtual cam final shot that we just created. Drag it into the inspector, and we're good to go. Okay. What you want to do now is save your scene, turn off everything. Let's make sure everything is back to normal. So we want to start with the game, the intro cutscene holder on. Let's save our scene, run Unity, and see if this works. I'm going to fast forward ahead to the last 5 seconds of the cutscene, and I'll see you once I'm there.
This ain't my first rodeo, cowboy.
All right, so let's see here.
Noted.
We're going to fade to black. All right, so we faded to black and our camera got repositioned over here. So what exactly went wrong? What happened here? If we look at this camera, if we were to turn this cutscene back on, turn on the whole object here. For some reason, we did not go through this properly. So let's go ahead and make it so we can preview this. So if you select your intro timeline, we should be able to preview this. And it looks like right now, oh here, go ahead and stop playing in the Unity editor. We want to be able to preview this timeline. So here we are. We fade to black. And at this point, we should be on this camera. And it looks like we are. You can see here in the scene view, the red camera's here. And then it goes to that. So basically, our camera, our main camera is just not syncing up to it for some reason. I'm going to run this again. And I want to take a look at some of the things that are going on in our intro cutscene here. So I'm going to fast forward.
I'm here.
Good.
And it looks like if we pause it in here, I'm going to actually pause it when it gets to that point in the video. So let's go ahead and run this again. When it gets to that virtual cam, I'm going to pause it. Let's see here.
I'm here.
Good.
Okay, so here we are. We're at the very end here. And what I want to do is I'm going to go ahead and unpause.
Cowboy.
Noted, noted.
All right, and let's get to that virtual cam here. All right, so right now, our virtual cam is active. And what I want to do is I want to double check. I want to hide, while the game is running, I'm going to hide this canvas element. So we are looking at the correct spot. The question is now is why aren't we, well, why is it going back to something else, right? So what I think we might be able to do is to prevent it from doing this specifically. We can then hop into our timeline asset here for the intro cutscene and change the wrap mode from hold to none. I think that may have something to do with it. I think it's keeping the last frame of something, but we actually just want it to be none for the wrap mode. And let's go ahead, run this again, and I'm going to pause it, and I'll meet you guys back at the very end of the animation. Okay, so here we go. We're at the end. And let's see what happens here. And I'm going to pause it real quick. I want to check something in the timeline here. So by the time any of this happens, I just want to make sure we're not actually closing the cutscene. We are on the length of this frame. I'm going to set this to be the end is 3750. So there's 3,750 frames. So I'm going to just set it to 3750. Now it's going to stay to the very end. And there we go. So that was the issue. The frame for the last camera must be at the very end. Otherwise, it's going to go back to wherever the last position you had the main camera. So that fixes that issue. And if we click, now we have control of Darren. All right, guys, I'll see you in the next video.
If you toss a coin in another
Now that our intro cutscene is working exactly as we'd like it to, we're going to create the functionality to press the S key to skip our cutscene. Now, in order to do this, we need to actually gain a reference or get a reference to our intro timeline from our game manager. So this playable director component holds the timeline asset. So we need this component specifically, the playable director. So let's open up our game manager here. We need a reference to our game manager. So just like any other component to get a reference, right? We could say here, public playable director, because that's the component type, right? But I can't type playable director. Why not? It's not showing up in my tooltip. I know that my tooltip is working because I can see other things. The reason why it's not showing up is because it requires a library. But how would I know what library it needs? Let's hop into Unity's API by going to Google and typing in playable director Unity. This will bring you to the scripting API for the playable director. From here, we can see we can do all sorts of things, such as view the properties that are exposed to us in the inspector. And then here are methods that you can actually act upon through code on the timeline. So for instance, if we wanted to play a cutscene through code, we can do so. If we want to stop a cutscene through code, we can do so. So what is it that we're trying to do? we want to basically stop playback of the current playable and destroys the corresponding graph. That actually might be exactly what we want to do. We want to stop the cutscene when you hit the S key. So now there's no code example here. However, we know that the syntax is going to be, once we get a reference to our playable director, it's going to be .stop. So let's look at how to actually, let's see if we can find a code reference here that would tell us how to use our playable director. If you're not able to find anything on the scripting reference, go ahead and type in how to use playable director from Unity C#. By putting C#, we should see some Unity answers or some forum questions related to it. Just looking and reading some of these links here, you see here we have scripting API playable. And then here we have scripting API playables.playableDirector.setGenericBinding. Let's just take a look at this for a minute. One of the things that's really interesting here was that playable keyword. And you'll see here that it says scripting API playables.playableDirector. Why would they type playables.playableDirector? And if we look at playable here, this says here unityengine.experimental.director. This is an experimental API. And actually, it looks like this is legacy code here. But what's important here is this playable here. This looks like it has access to the timeline stuff. And what it is it's a Unity Engine API. It's basically a library similar to working with the AI or the UI system. So if we hop back into Unity here, you can type using Unity Engine, and very similar to UI or AI, we're going to say using Unity Engine.playables. And that's going to give us access to the playable director. And you could have found this out by also just searching for other playable director with C# or access playable director with C# from Unity and Google, and you would have came across something with playables. Now by adding that namespace, it opens up the library to interact with this code. So here we can actually type public playable director, and we will call this our intro cutscene. Intro cutscene. We'll save this. Let's hop back into Unity. And on the game manager object, we're going to have a slot available to drag our playable director. So let's go ahead and run this. And there's actually a few ways we could achieve the same result. So we're going to drag our playable director in there. Another option actually would have been to simply just turn the parent game object off when the cutscene is running, but then we might not get our player back. So there might be some setup that we have to do. So we'll go ahead and figure that out together. So here we go. So right now our game manager has access to the intro cutscene. Now when we hit the S key, what do we want to do? We want to basically stop that cutscene. So to create functionality like that, we need an update method to check for user input. So in here we have public void update, and then we're going to check for the S key. So if we hit the S key input dot get key down, and if the key code is an S, then what we want to do is access our playable director, which is our intro cutscene. And from here, we want to say stop. So let's save this, head back into Unity, and let's see what happens. I'm picturing it just shutting off and stopping entirely, and I think our main camera is going to get screwed up in the process, as well as our actor won't be present. So we may need to consider moving this possibly to the very ending, to the very last frame. But let's see.
I'm here.
So I'm going to go ahead and hit the S key.
I hope you didn't run into any trouble. Darren,
And just as
you
I
made
thought,
it into the grand foyer of
so there's a few
miniatures
issues here.
auction house.
It stopped the
The
timeline,
items in this room
but our voiceover was still continuing and our main camera got screwed up. So maybe that's not the best solution. So what else could we possibly try? One of the things that comes to mind is what if there was a way in Unity to basically say, hey, if this timeline is, say, let's look at it in seconds. If this timeline is 62 seconds, let's skip to the very end when we actually start fading out, right? So what if we could skip to like the 60, 61 second mark? Let's look in the Unity API and see if there's anything available in the playable director for us to do that. So let's type in playable director. And we want to find a solution here. Let's see. Here, I'm going to go to playable director in Unity. Let's get to the proper scripting API. Here we go. So what are some of the functions we have? We have set generic binding, which sets the binding of a reference object. Not really what we want. We can pause, we can resume, we can play. We can, let's see here, inherited members, public methods. Not really useful. I'm not necessarily seeing anything that's going to let us like choose a keyframe or fast forward in time. Although there is an initial time, which the time at which the playables should start when first played. Time, the component's current time. That actually might be something. The component's current time. This value is incremented according to the playable director.time update mode when it's playing. You can also change this value manually. Let's check that out. The component's current time. The value is incremented according to the playable director when it's playing. You can also change this value manually. I wonder if we can access the time property and set it to about 60 seconds in. Let's give that a try. When I hit the S key, we're going to say intro cutscene.time, and I can. It says get and set, which means it's a property, so I can set this. And let's try setting it to 60.f or 60.0f. Let's save this. Head back into Unity. Let's run our game, and let's hit the S key. Here we go, loading up. All right, so we're gonna drop down, I'm gonna hit the S key.
Oliver, I'm here.
Good.
And that actually worked really, really well. So that was perfect. That's exactly what we want. Yeah, that is literally perfect. So that was awesome. Now, one thing that occurs when we do that, we wanna make sure that our background music is actually on still. Make sure that everything had a chance to become animated. So if we look at our audio manager here, and if you look at our voiceover music, it is. Alrighty. Good deal.
Oh man. Hey there, Darren.
Cool. Good deal. One last thing I want to check here is I do want to make sure I couldn't really hear my music, the background music, so I just want to make sure that it is running. Make sure it's not too low. So I'm going to hit S.
Oliver,
there we go.
I'm here.
All right, here we are. And if we look on my music here, I actually can't hear the music here. And I think it's because it's not necessarily playing. So I may want to create something that's going to tell my ambient music to start. So let's go ahead and do that. If we look at our audio manager, we can create something in here that's going to allow us to play the music. So if we get a reference to the audio source that holds the music, we can save this. In Unity, you can get a reference to that audio source, and then we can have a function in here called public void play music, and we're simply just going to type music.play. And that's going to actually allow us to then say audio manager.instance.play music. So if we hop into our game manager script, when we hit the S key, public void update, if input.getKeyDown keycode.s intro cutscene.time equals 60, then the next thing you want to do is you want to say audio manager.instance.play music, and that will play our music. So let's save this, hop back into Unity, open up the audio manager, and let's make sure everything is okay. You want to drag inside the music property. You want to make sure that you give it this music audio source. All right. So once that's assigned, let's go ahead and run it one more time, and we should be good to go. Here we are. I'm going to hit S.
Oliver, I'm here.
Good.
And there we go.
I hope you didn't run it.
Good deal. And if you wanted to, you can even adjust it even further. You can change the volume properties and so forth. Alrighty. That's everything for this video. I will see you guys in the next lesson.